Welcome to the mathematics and a new video on the JEE advanced series. We discuss a question from 2020 sheet 2, and before we start I want to give some general hints and hints for the solving strategy before we take a look at the details. So first of all, it's very important to read the whole task carefully and think about the given conditions. What do you know about them? Why are they there? Why are they written? What might help? And if there are a couple of answers, you can choose. You can also think about what they tell you about the solving strategy and how to prepare in general. Of course, you should know about standard techniques like geometric series, telescoping sums and stuff like that, and you should know about some basic properties about important concepts, for example Riemann integration and stuff like that. And also something very important: do not work stupid, think smart. Why I write this here? Most of the exams look horrible, but the structure of the task gives you many hidden hints. You will see that also here in this example. Okay, and if you know them a lot or enough about certain stuff, the problem is easy. Let's take a look. 2020, sheet 2, question 16. I changed that a little bit. Let n greater be 0 natural and b greater 0 real. Define f of x 2b to the power x over 2b to the power x plus b for x in the closed interval 0 to 1. Evaluate the sum from I equals 1 up to 2n minus 1, where I is not n, over f of I over 2n. I changed this a little bit. I generalized this problem. In the original exam, b is 2 and n is 20. Alright, and I changed it a little bit, but the problem is the same. We read carefully. It's about a function and a function f, and we want to find a strange summation. Strange in the sense why I is not n. And what might help us? Maybe we should take into account the geometric series, or maybe some kind of symmetry, or maybe some kind of Gaussian sum. What I mean by that is the first plus the last and stuff like that. Maybe this can help us. And do we get hidden hints from the answer or from the task? Yes, in some sense we do. Why is I not n? And why is there the closed interval 0 to 1? And these 2 points leads us to consider f of a special value, and we will see. We will find the special value. So first we play around with this sum. And I should say, if you are familiar with some functions like that, then maybe you know what's going on here. This is sometimes also in the MIT integration B or something like that. There are a couple of these functions, and the trick is always the same: to use some kind of symmetry, and we will use the symmetry here as well. But how to spot this if you do not know it? This is what I want to talk about: how to spot the symmetry if you have no idea. First, what is the first step we do? We separate the sum from I up to n minus 1, and then from n plus 1 to 2n minus 1. Okay? The next step is to change the index of the summation. In the second sum, we subtract n here and here, so we get the same summation here, and we have to add n in the argument of the function. Okay, so it's just a simple index shift. Why we do that? We want the same index for both sums. Okay, so make sure you got the idea here. And now we want to separate this ratio, but in a clever way. And what do? We change the order of summation. Instead of summing up from I up to n minus 1 from n plus I, we make the order from I equals 1 up to n minus 1 of 2n minus I. So instead of summing from left to right, we sum from right to left. Okay, so if you write down a couple of values, you will see what I did here. And why we do that? All I want is, I want to write down the second argument as 1 minus I over 2n. So we have the same arguments. This is why I want to do that. And then we know what's going on with the symmetry. Now the summation is here the same, so we can add these two values. And now we have here f of x plus f of 1 minus x, and this is the symmetry what we can examine. And when you do that, it's an exercise for you. If you add f of x plus f of 1 minus x, you get 1. I leave that as an exercise for you. Okay. It's not so difficult. Here again, how to spot the symmetry. We play around with this sum and we make advantage of I is not n. So we can separate this sum. We change the index. We change the order of summation from the right sum. We separate the fraction on the right sum, and now we have our symmetry. And yes, it's an exercise for you. If you sum up these two functions values, you get 1. And yeah, the next part is easy. Sum from 1 up to n minus 1 over 1 is n minus 1 times 1, and this is n minus 1, and that's the result. Alright, that was question 16 from 2020 Q2. Have fun, enjoy, see you next time. Bye bye.